Hi there, students. Well, before the break, I have already talked about reading, view reading. Well, we have orthographic views on the sheet. Drawing sheet. We have the necessary views and dimensions, and title block has been filled. And for some features, some technical notes we have, some annotations. If the sheet is for describing the shape of a single component, single object, not that of assembly, but a single object, okay? And on the sheet we have the necessary views and the dimensions of the features of the object. And the title block has been filled and we have the necessary info within the pigeonholes of the title block. Then such a drawing sheet is called detailed drawing sheet. It is a kind of engineering drawing, you know. Saying view reading just before the break, while White talk about what is view reading. Look at the views and then achieve to see the object thanks to your learning outcome, thanks to your experience on view writing, view drawing, and also view reading. Start seeing the object in your mind, three-dimensionally. That is the meaning of reading. Looking at the views and gathering the dimensions, of the features and entirely of the object, and thereafter visualizing the object in the mind to mind eye means reading. Previous video record, I think, is sufficient on the meaning of view reading. In detail, I talked about it and said that if the background of the reader is sufficient, then he or she can achieve reading. Saying background, if the reader knows the alphabet or the language. What is that? Engineering drawing is a language, you know. If the reader knows the types of lines, means the alphabet of the language, which kind of line is used, on the views, on the engineering drawing sheet to say what. If the reader knows the meaning of some standard symbols, such as quadrant symbol, diameter symbol, radius symbol, contour borehole symbol, contour sinkhole symbols, and aware on the dimensioning format, it is expected that the person can achieve reading. Of course, if the experience of the person on the writing part of the language, I mean view drawing, view creation, and also on view reading, if the experience of the reader is not so good on writing, reading part of the language, then thanks to his or her background on view reading, engineering drawing, in time reading is achieved. Person can achieve to visualize the object in the mind. But if the experience of the person is good enough on writing and reading part of the language, then at much a shorter period of time, that person can achieve reading. Now here in this record, I'm going to give an example. In the example, the object to its geometric shape going to be to its level of difficulty, can say that medium level. Not so simple, not very difficult, moderate level. Well, if the object is a little bit complex in shape, of course, looking at the given engineering drawing, looking at the given orthographic views, reader may not achieve reading the views well in few minutes, even seconds. Well, reading in such a case will take a certain time. Okay, now, example. Yes, this is an engineering drawing. Since it is to explain the shape and provide the size of a single object, can say that it is a detailed drawing. It has not been completed. Why? Because at the title block, well, one of the most valuable info is available. It is the quadrant symbol, but the company name not written. General tolerance note has not been written yet. Name of the object has not been written. Scale factor not written. Material of the object has not been written. So, well, since the title block has not been filled yet, so cannot say that it is a complete engineering drawing. Okay, well, but the views and the dimensions are complete, okay, to achieve reading. And the views are consistent with each other. Well, if the views have been created, bringing the cursor to the vicinity of the base view, normally front view is created first and say that it is going to be base view. Okay, you know the advantage of creating the front view first. Well, bring the cursor to the vicinity of the front view and then left click the mouse. Well, in AutoCAD, in Inventor, well, while doing this, we are doing this, bringing the cursor to the vicinity of the base view and left clicking the mouse, can see the joining lines between the views. See, between the front and the top view, yes, now I have a joining line. And similarly, between the front view and the left side view, there is a joining line. It is the indication that views have been created consistently. Actually, the views are created as consistent with each other. Well, Inventor considers that between front and the top x-axis is used. Say front view and the left side view use the same z-axis. Top view and the left side view use the same y-axis, y coordinates, okay, respectively. For instance, this point is A. On the front view, on the top view of that point, the abscissa value is the same because it is the same point. In Inventor, clicking on base button, base view creation tool only one time at the beginning can guarantee to have the views as created consistent with each other. Well, for the other views, dependent views, projected button is clicked. Well, not user, but the software. On behalf of the user, software at the background, while the views are being created, projected button is clicked. And the other views are created as dependent views, while using the same coordinates, okay, for the same characteristic points respectively. Inventor can create the views. In AutoCAD, one more time, say such things. In AutoCAD, using the two-dimensional part of AutoCAD, well, we start from transfer lining stage, drawing the transfer lines, and at the intersection of the transfer lines, having the images of the characteristic points as consistent with each other. Well, have the views consistent with each other. Well, for instance, creating this transfer line using the abscissa value of point, let's say A, okay? Well, along the same transfer line, we have the other side image of that point, okay, on the top side view at the correct place. How? Using the same abscissa. Since the abscissa value must be the same, this means the top view, other side view of the same point must be along the same transfer line, where at the intersection located by that transfer line and the other transfer line. This transfer line uses the y value, ordinate value of point A, the selected point. Well, actually, already talk about such things at this stage while studying at that time we were studying on orthographic projection and how the views are constructed. Studying on such things, well, sufficiently talk about the consistency requirement and the thing to do for having the views as consistent to each other. But here the time is view reading time. Okay, now the example which I selected is this one. Okay, let us start and achieve reading. Well, here looking at the views, okay, check whether it is possible for you to see the object in few seconds, okay, three-dimensionally in your mind. If the answer no, why? Because object has more than one, two features, combined features. It has, well, more than few features, so object is a complex object with its geometry, and say that it is the case. You never seen such an object beforehand. For the first time, you need to deal with the reading stage on that geometry, on that object. The object may be very complex in shape, but if the reader has already studied on such a geometry, the same example, same object, the views of the same object or a very similar one, although object is in a complex shape, then reading may be achieved in even few seconds because it is the same object. Reader has already been studied on it. But the studying is for the first time, then yes, since the object is a little bit in complex or maybe even really very complex in shape, then yes, view reading will take a certain time. Okay. View reading, in this example, say that assume in the scenario you never seen such an example before, so for the first time gonna study on this example. And then you had a look at the given views and it is your case. You're saying that, yeah, well, it is difficult, so couldn't understand, couldn't visualize the object in the mind. Okay, well, first start from here. You know, view reading is to be started from the title block, which pigeon box? The pigeon box in which we have the quadrant symbol. Okay, to be able to say something on the page, you have which side views. Then the first thing to do is that, what is the quadrant? Which quadrant has been selected? Well, the quadrant is the first quadrant or the third quadrant? That is the question. Quadrant symbol, yes, of course, thanks to your learning outcome or studying, you learn the meaning of this symbol by heart. It is to say that first quadrant. Okay, then, well, after saying first quadrant, after seeing that it is first quadrant, and from such a studying, you know, if it is first quadrant view, then, well, you know the principal views. Well, which principal views find their places relative to each other where on the page. Okay, well, the grammar of the language means orthographic projection. The theory orthographic projection, ABC of orthographic projection, is the grammar of the language. Well, in this example, for instance, you know quite well, well, this is the front view. How you can understand that not this but that one is front view? You know, from this fact, we have the picture planes, okay, and revolving the picture planes in the standard directions, okay, can obtain top view under the front, bottom view above the front. If it is third quadrant projection, above the front we find the top side view. This is the top side view. Quadrant is the third quadrant. But say it is the only view above or below we can have another principal view. So from here can see that this is the front view. Under the front view, well, if the quadrant is the first, we have top view. If the quadrant is the third, we have the bottom side view. If the selected quadrant is the first, next to front view at the right side here, we have the left side view. But if it is the third quadrant projection, at the same place, we have the right side view. Well, already studied deeply on such things. So, well, since you study on the writing part of the language, you know what is orthographic projection, how it is drafted, which quadrant is selected, etc. And you learn the relative locations of the places for the principal views. Okay, then here on this example, after saying that the first quadrant, then see on the page how many views have been provided. 3 views. And then first quadrant projection, you see under this view there is nothing, but under that view we have another view. So this means this is the front view. My cursor is indicating this is the front view. Under the front view we have the top view. Next to front view we have the left side view. Okay, front view, top view, left side view. And then, well, how about dimensions? You know, between the front and the top we have the x-axis. Okay, well, here, yes, this is the same example. Well, take a drawing facility, say pencil or line drawing facility, and then, well, select the thickness. Okay, you know, this is the front view, but this is the top side view, this is the left side view. Okay, you know this. Between the front and the top, yes, you know, we have the x-axis. Okay, if you want, show the arrow to say that the x-axis extends to the left to its positive side. Abscissa axis, this is the abscissa axis, and this is the z-axis along which we mark the altitude values. Okay, in constructing the views, that is the positive sense of the z-axis. And here we have the y-axis, of course horizontal oriented. It is used in constructing the left side view, or in general speaking, say profile view. Okay, y-axis. Constructing the top view, okay, y-axis will be directed vertically in the down direction. Okay, write the ID letters of the axis. Well, this is the z-axis. Okay, this is the x-axis. This is the y-axis. This is the y-axis. Okay, so, well, width of the object, in general saying, we say width, this means the overall width. In this example, you see the width of the object is delta x, means it is over here. Well, see the width value. This number is the width, 64. Okay, height, well, this is the height, delta z means height, 31. And 63 is the depth. Delta y is the depth value, depth of the object. Yes. But here you see in the scenario, in the example, say that object is not simple in shape, so couldn't achieve reading in few seconds. Still thinking. Well, my method. Discretization uses discretization technique. First, see for you which view is more understandable. Have a look at front view. Not so understandable, especially in terms of the entities, whether the entity on the view is the view of an extension or the view of a cavity. For instance, looking at this view and here finding this rectangle on the front view, cannot directly say something that it is the view of an extension or it is the view of an empty space, cavity. I can say similar things for this rectangle. But looking at the top view, you see, well, this is the part of the projection. It is in the atmosphere at the outside, and no doubt this is an extension. If it were within the object, a feature, then it would be hidden like those. These are hidden lines. Okay, so looking at the top view can directly say that yeah, there is an extension here and there is an extension there. So relative to the front view, comparing with the front view, since looking at the top view can distinguish which features are extensions, okay, directly can see this is an extended feature, this is an extended one. So, the answer of the question, which view is more understandable, can say that top view. Why top view but not the left side view? On the left side view, you can see that there is an extension, there is an extension. Here, the most difficult one to read is the front view, because looking at the front view cannot see which one is an extended feature. Looking at the top, can see that this part extension, this part is extension. Looking at the left side view, can see that this triangle on the view corresponds to an extended feature. That one, longitudinal axis is shining and obvious that this is a cylindrical part. It has only one diameter value. It has been shown. Diameter is only one diameter we have. So it is a cylinder, obvious. Left side view also is relative to the comparing with the front view is more understandable. What I mean, at the beginning, select a view. Okay, looking at the view can see the features, whether these are extensions or within the main part of the object. Select front, top view or the left side view. Since on the left side view I have broken out section, and say that in the scenario for the person existence of such a sectional part made the view a little bit more difficult. But on the top view there is no such a advanced application. Say that in this example for this object, top view is the easiest one to deal. Okay, so which view is easiest for you to start? It is more understandable relative to the other side images. Then, my method, select that view. And then, divide the object into sub portions. In doing this, okay, try to divide the object such that to have the divided portions in basic shape. Most of the cases we obtain basic geometries when we divide the object into sub portions. Why? Because the designers just at the design stage using simple using the features, combined features in basic shape, using them in relation, combining them, design a complex object in shape. Well, as designers, we use rectangular prisms, triangular prisms, okay, cylinders, conical parts, rectangular prismatic empty spaces, holes, okay, contour borehole, contour sinkhole, etc. Well, using those combined features in the design of a body, we obtain the object in say complex shape, okay, depending on the demands of the customer. Designer, while bringing the features in basic shape, cylinder, rectangular prism, triangular prism, conical features, etc., can obtain the object in a relatively complex shape. And in that shape, it is for satisfying the expectations or demands of the customer. So since it is so, well, at the discretization stage, well, we can find the features, combined features, in most of the cases, of course, not always, but most of the cases, in basic geometry, basic shape. Okay, now, see. Say that in this example, top view is easiest view to deal, so I selected top view to start. Okay. And then, on the selected view, make a discretization. Well, in doing this, well, first see the biggest one. You see on the top view, I have some sub-regions, the views of some features, the views of the features. Object, okay? Well, a single component, but it consists of some features, combined features. Okay, and their views on the view just in form of closed profiles. For instance, here, now I am bounding it, there is such a part on the view. Okay? Well, divide the view into sub-portions. Well, this is one of them. It is a rectangle I see. Okay, say that this surface is 1, S1, surface 1. Okay? And another surface here on the view, yes, it has its own boundaries. Another region, another combined feature, the view of another feature. So say that that surface is the second surface. Okay? And here there is one more surface, say that S sub 3, third surface. Okay? Well, a surface bounded by a visible circle, say that fourth surface. Okay? Continue. Here on the view, another region I have, say that it is the fifth surface, S sub 5. Okay, a hidden rectangle I have, and the surface bounded by hidden rectangle is surface 6. Okay, and two more. Well, within this rectangle, hidden rectangle, there is one more region. Now, I'm bounding it. Yes, say that it is seventh surface, surface 7. And within this part, or say on the view, there is one more region. Okay, it is the 8th region. On the top view, while making such a division, discretization, I found 8 different regions. Okay? And then, well, start from the first region. Well, focus your attention to that surface, and well, for that surface, ask this question. Okay, that surface is the view of which feature of the object? That feature is in which shape? It is in which size? That is the question. Okay. Now, yes, the surface which I selected is which one? Now bounded it, this one. Okay. First, achieve the reading for this part of the projection. Okay, it is the first surface. How you can achieve reading? Okay. Well, at that stage, the transfer lines will help you. If you follow the transfer lines, you can find the other side image or for the selected surface. Well, this surface on the projection, this region on the projection, is the top view of a feature. Where is the front view of that feature? Which part of the front view corresponds to the front view of that feature? That is the question. Well, in answering the question, this question, well, take this color, blue, and the line thickness. Okay, I think this is suitable. Transfer lines will help. Okay, after selecting this surface, say that it is surface 1, this surface, and then consider the transfer lines passing through the limiting points of the selected surface. One of them is over here. Try to locate it. Now this is the one of the transfer lines. Well, at the view creation stage, inventor at the background used that transfer line. If it were AutoCAD, the software were AutoCAD and the selected mode is two-dimensional, then yes, at the view construction stage, this will be the one of the transfer lines. Okay, to have the top view and front view of the feature. Okay, this rectangle corresponds to its top view of that feature. This is going to be one of the transfer lines. But at the view reading stage, yes, see the transfer lines and then follow like a path, like a guide. That's why the transfer lines actually at the view reading stage are called guidelines. Yes, I am recording the things, okay. And then, well, this is the transfer line. It is passing through the limiting points of the selected surface. Okay, selected surface is this rectangle. Okay, this surface bounded by this rectangle. Okay, and this is the other transfer line. It passes through the at the other side again through the limiting points of the selected part of the projection. Well, you know the ABC of orthographic projection. Since the x-axis is commonly used by the top, by the front side view, for the same characteristic points selected on the top and say the corresponding views on the front, the abscissa value will be the same. Ordinate value will be the same. For instance, say that this is point A. This is the front view of point A. Where is the top view? Top view of point A must be along this transfer line, because the x-axis is commonly used. You know this. While here at the view reading stage, we use this fact, geometrical fact. Since the x-axis is commonly used, okay, if the top view is between this transfer line and that transfer line, then the front view of the selected part of the object must be between the same transfer lines. Well, follow this transfer line, follow that transfer line, and then see between them where at the place over there we have the front view, we found which part of the projection. When we follow this transfer lines, you see between them on the front view, I obtained another rectangle. Here is the rectangle. Yes, something like this one, this rectangle. Yes, on the front view, correspondingly, I found another rectangle. So top view is rectangle, front view is a rectangle. Can we say that at that stage, after finding on both of the picture planes rectangle between the same transfer lines, ensure that the views are consistent views, they use the characteristic points use the same abscissa value respectively A, B, B, C, C, etc. No, not yet, because there is one more view. If on the page there are two views only, then yes, achieve reading looking at two views or making such a control for two views. But if you have three views, then well, find top view, front view, and also for the selected feature, have a look at the left side view. And then thereafter can say something about its shape, about the shape of the selected feature. Okay, you know, this is the coordinate system, and well, to be able to have the same y value here and there, you know, we use cosine 45 is equal to sine 45 equality. Graphically how? Graphically, well, using such an inclined line. Okay, it is inclined, and its inclination angle must be 45 degrees. Okay, it is called mitral line. Okay, this angle is 45. Well, then see, this is the front view. This rectangle is the front view of the selected feature. That rectangle is its top side view. How about its left side view? Well, if the front view is over here, yes, well, now between the transfer lines, this transfer line, now similarly on the front view, well, distinguish the transfer lines passing through the limiting points of the selected part of the projection. Well, this is one of the transfer lines. Okay, follow this transfer line. The other transfer line is passing through the other extreme limiting points. So, well, you see, the front view of the selected part of the object is between this transfer line and that transfer line. Since the z-axis is commonly used by the front view and also the left side view, then can directly say that if the front view is between this and that, the left side view of the same entity, we selected that entity, okay, and trying to understand its shape, must be between the same transfer lines. Okay, between this transfer line and that transfer line, we must find the left side view of the selected feature. But where? Shall we consider this part left side, this part left side? Well, the answer, without any doubt, comes from the top side view. Well, the top view is between this transfer line. Well, sorry. Well, actually, it is now passing through the terminal points of the selected part of the projection. Here I have a rectangle, and this is the other transfer line passing through the limiting points of the selected part of the projection. If the top view is between this and that, those transfer lines, then well, it is left side view must be between the continuation of the same transfer lines. Okay, trying to draw the lines. Well, I think the angle is not 45. That's why, well, here I had this line well, little bit inclined. But here what I say, since the y-axis here and there the same axis, well, if the top view is between this transfer line and that transfer line, then the left side view must be between the continuation of those transfer lines. After reaching to the mitral line, we change the direction and go in the up direction. Reach to here, and after this intersection point, change the direction and follow the transfer line. This is the rest of the same transfer line. This and that are used to transfer well value, ordinate value from the top to the left. Since the top view is between this transfer line and that transfer line, then it is left side view must be between this and that. So well, left side view must be between this and that, those transfer lines, and similarly must be between this and that. So what does it mean? This means the left side view of the selected feature well, must be in the region it is bounded by those 4 transfer lines. Okay, well, here between those transfer lines, you see what we have another rectangle. Yes, on the top view, the first feature, as it is top view, okay, there is a rectangle. For that feature, when we refer to the front view, following the transfer lines, those passing through the limiting points of the selected part of the projection, we found another rectangle. And then following the transfer lines, okay, passing through the front views of the limiting points of the selected feature, and also following the transfer lines, these are passing through the limiting points of the selected part of the projection, which is on the top side view. And between this and that, finding one more rectangle. Now, at this stage, for the first feature, can say that it is a rectangular prism. If the feature to it is all the views, just front view a rectangle, top view rectangle, left side view rectangle, we find rectangle as it is corresponding images. Know that object is a rectangular prism. After saying that, yeah, well, geometry is a rectangular prism, okay, then, well, see, okay, what about the size? The first feature, we conclude that is a rectangular prism, okay, then, but in which size? Well, answer the question, of course, referring to the dimensions which have been shown on the paper. Yes, this dimension is the overall width. I see it is 64. Okay? Well, on the left side view, that dimension, you know, delta y is the depth value, 63. And here, this dimension 31 is the height of the prism. Okay, and then in my method, after saying that that is the shape of the entity which you selected on the simplest projection, it is image, and then, well, following the transfer lines, you concluded that it is in such a shape, then, well, before dealing with the other part of the selected projection and similarly, well, achieving reading for the selected portion of the body, well, open inventor and then create the model of that feature. And then, to be able to verify that your reading is correct in shape and in size, yes, that is the second tool of my method. Yes, create the model of that feature of the object and create it as orthographic views. when you create the views of the feature, if you find the same images for the selected feature as they are shown or given on the sheet, if it is school, your case is just exam, you're taking the exam. If on the exam sheet, okay, as they are shown, you obtain, when you create the views of the selected feature, you had the same images as they are shown, as they are given on the exam sheet, and also the size, then this means it's great. Your reading is correct. Okay, then see, I'm going to apply my method. After concluding that the selected feature is a rectangular prism, in Inventor, I'm going to create it. Okay. Of course, this is the complete set of views. But here say that my reading for the first time. So open a drawing file. Not drawing, part creation file. Clicked on new file creation button, and then, since in this example the given on the given sheet the dimensions are all in millimeter. How I conclude that these are millimeter? Because quadrant symbol is the first quadrant symbol. So since I know the size of the entities in millimeter, for my convenience I'm going to use not English unit system but metric unit system. I selected metric option and then part creation template. Clicked on create button. And then model creation starts from sketching stage. Clicked on 2D sketch button and then select one of the coordinate planes. It is my convention. I select the horizontally oriented coordinate plane as the coordinate plane to coincide the first sketch plane. Make a click. Then in sketch mode, since I concluded that the selected feature is a rectangular prism, I am going to create a rectangle and consider this rectangle as the bottom side surface of the prism. And then, input the dimensional constraints. I see that the width of the prism is 64 and the depth of the prism, the depth of the object 63. But the depth of the selected part of the object, my method used discretization technique. I divided the object into sub portions. Okay? Feature by feature, started to read the given views. First feature, it is a combined feature, is a rectangular prism, and depth is 37. Can you see? Yes, this dimension is 37. This dimension. So, since in my consideration this rectangle is the bottom side surface of the combined feature, I said that it is a rectangular prism. Then accordingly input the constraints. Clicked on dimensional constraint button and indicate this boundary with a click, indicate the opposite boundary with another click, and then move the cursor in the vertical direction, and after the third click into the box it will appear. Write the size. It is how much? Yes, it is 64. Okay, 64. Input. Okay, and the height of the rectangle, since I said that it is the bottom side surface, corresponds to the bottom side surface of the object. It is depth of the object is the height of the rectangle. It is 37. You see this number 37. Okay, then dimensional constraint from here to there, it is value 37. Finish the sketching stage. Clicking on Finish Sketch button and apply extrusion process. What is the height of the feature? Yes, the height of the feature is 31. On the front view, I know that height means delta z, and I know that delta z is shown either on the front or the left. On the left side view, there is no such a dimension, but on the front view, I see that 31 is the overall height. Okay, so 31 is the extrusion distance. Into this box, write 31. And then say OK. And then this side, well, here in my consideration, this is the front side of the feature, this is the top side, this is the left side. So without forgetting or starting to confuse, I'm going to teach to the software that this orientation is the suitable orientation, okay, for me, and define this positioning as it is home positioning. Bring the cursor onto cutter symbol, right click the mouse and select this, bring the cursor onto this option, jump to this sub window and select fit to screen option. You know this. And then, well, this is the top side, this is the front side, and that is the left side. Okay, of the feature. Okay, then save this file in the memory. The model creation stage is okay. Okay, and then, well, save as. Show the address. Well, I'm going to save this file in, I know where it is, in this partition, and this folder, that subfolder. In my computer I have lots of subfolders, so address is a little bit long. Okay, and then say that surname, you know, my kind request, generating the names of the files, then write your surname in English, using English alphabet in lowercase. Write your surname first, and then ID number, okay, and then say that reading example. So since this is about reading, I'm going to use this word reading. Okay, and date of today is the 5th of June, June 5. Okay. And then my method. Well, after achieving reading on the selected feature of the object and then creating its model in Inventor, then yes, to control whether your reading is correct in shape and in size, create the views of that feature. Okay. Clicked on New File Creation button, and then select the quadrant. If you select metric option, then this means you selected the first quadrant. Okay. You know, in this example, on the given engineering drawing sheet, the given views are the first quadrant views. So, well, to be able to check whether the views when we created for the feature gonna be the same, so our reading can say thereafter that is correct, well, select the same quadrant and obey to the rules of ISO template, and then click on Create button. Okay. Size of the paper. Well, check well on this complete projection the size of paper edit sheet. I see A2. A2 is the most suitable. How about the scale factor? Well, scale factor is 2:1. Okay, I'm going to use the same size of paper. Well, the default size, it is selected by Inventor, is A3. Bring the cursor onto sheet icon. You already learned such things, how the paper simulation is edited in size and shape. Well, select Edit Sheet option, and then not A3, but from the list select A2 size paper, and then say OK. And start the view creation process. Well, here you see in Inventor, well, the model of the feature is still active. So since it is the lastly studied file, when I clicked on base view creation button, Inventor will automatically sense that it is this view creation, that view creation is for that available, for that active model. If the model file is closed, not active, but it is in the memory, then clicked on the search button and then show it as address. You know this. Now here I'm going to clicked on cutter symbol. Since I have already fixed that this is the front side. Well, enabled myself to see the model as I fixed in home positioning. And then I know that this surface of the cube is parallel to the front side of the object. Then well, teach to the software that going to create front view. Clicked on the surface of the cube. It is to make the front side of the object correspondingly as parallel to the drawing paper, and then say that this is the front view. Scale factor, well, I see from the already completed one is 2:1, suitable. And then since it is not a sectional but normally created view, well, the first style button must be on. If this button is on, then Inventor can create the images of visible and hidden features, all the features. So this is the correct style option. And then we know that front view is created not here, but using that part of drawing paper. So hold it and drag to such a place. Okay. And then say that this is the front. Move the cursor in this direction, make a click. It is to create the, to have the top side view. Move the cursor here in this direction, make one more click, and then say OK. Yes, after creating the views, have a look at. Yes, on the given sheet, yes, the first feature which I selected, it is top view, rectangle, and following the transfer lines, you know, here, following this blue lines, I saw that it is front view is a rectangle, and following the transfer lines, I saw that it is left side view rectangle. Then let me check here. Well, when I created the views of the feature, found the same result. Yes, the answer is yes. Front view is rectangle, top view rectangle, left side view rectangle. Geometry is okay. Since I found the same projections, can say that my reading on the geometry, on the shape is correct. How about the size? Check whether reading is also correct in size and you created the model in the correct size. How you can change? How you can check? Just showing the dimensions. When you show the dimensions, if you obtain the same values, if you see the same numbers, 64 here, okay, 37 there, and 31 on the front view, then this means your reading is and also model creation is correct. These are correct in size as well. Okay. Well, since I'm going to show the dimensions here, you know, first I should configure the dimensioning facility. Clicked on Manage tab and then Styles Editor button. Yes, one of the chapters deeply studied on dimensioning part, and you know how the facility of Inventor, how the facility of AutoCAD is configured. Dimensional configuration stage. Clicked on in this dialog dimension option, associated cross, and then select the last option from the list, it will drop. And then yes, well, referring to the tolerance table for the non-functional features, general tolerance table, see the deviation starts from where? Well, the tenths, hundreds, thousands, 10,000s. Well, for the given object, already check, referring to the tolerance tables, you know how. I see that I know that the deviation starts from tenths. So while showing the nominal values, need to show them to their integer part. So well, from this list, in this dimensional configuration dialog, select 0 precision. 0 precision means, well, the nominal value will have its integer part. Okay? We are going to show the integer part of the nominal value. Why? Because the decimal part of the nominal value is controlled, is fixed by the tolerance of that dimension, by the deviation of that dimension. That is why. And then if there is an angle to show, then because of the same reason, precision is 0. Okay, in this dialog, you know, this is the thing to do. Select display option. Okay, and then at the beginning of extension lines, we leave 2-3 millimeters empty space. I selected 2. Okay, for the successive dimensioning rows, 8 millimeters is the minimum space to left. D is to be 8. Okay, well, the size of the termination symbol, in this example, it is a machine part, so mechanical engineering product. We use, you know, filled arrow. Okay, blackened arrow head as the termination symbol. But if it were the projection of a building, house, then we'll select oblique option, tick option. But here arrow is correct, and arrow size is 3. For A2 size paper, A3 size paper, the arrow size is 3. And then clicked on Save button. And then, well, text, I didn't configure the text facility of software yet. So, because I couldn't find time, just still talking about view reading. Otherwise, for instance, say that I clicked on text option and then, while selecting the option, then configure the text facility. But here, don't worry about it. While you're configuring the dimensioning facility, clicking on text button, and then in the dialog box in the pane it will appear. Just clicking on this button on which we have pencil point, you know, buffer jumped from the dimension option to the text option. Yes, you know this. And then in this dialog, the thing to do is that select the font name. Arial is the recommended font name. Font height, well, for A3 size paper, 5 mm as the font height is suitable. Select 5. You learn all of such things, well, in detail. In AutoCAD, how the dimensional facility is configured. In Inventor, how it is configured. How the dimension is shown. Already studied on all of such things. But here, just applying. Clicked on Save button. And then to be able to turn back from text configuration stage to the dimension configuration stage, clicked on Back button. Now buffer turn back from here to there and dimensioning dialog box. And well, the other things are all selected by the software, are all correct options. Then, well, tolerance, there is nothing to do. Options, there is nothing to do. But nodes and leaders, for having the leader lines with the necessary horizontal tail, from this list, after clicking on this listing arrow, dropping the list, select the first one. It is to have the leader lines with not only inclined but also horizontal portion, tail. Yes, saying dimensional configuration, I mean such things in short. Clicked on one more time, save, and then close button. And then yes, after configuring the dimensioning facility, well, I wonder whether my reading is also correct in size. Annotation and show the dimensions. Clicked on dimension indication button and then indicate this boundary of the front view and then move the cursor. Yes. And then check whether dimension is the same as it is given on the exam sheet. It is 64. Clicked on OK. and then check whether on the exam sheet the dimension is the same. Yes, 64. Okay. Continue. Well, the depth has been shown on the left side view, so indicate this and then drag the mouse and then check whether it is the same. Yes, 37. Height has been shown on the front view. Okay, indicate and then move the cursor and then check whether the dimension is the same. Yes, great. The views are the same. Dimensions are there, are the same as given on the exam sheet. So can say that achieve reading successfully, satisfactorily for the first feature of the object. Okay. And then, well, save this file after saying that achieve the reading for the feature. Okay. Say that the file name is blah blah reading June 5. Okay. And then continue. Well, for the first feature, our reading is okay. We achieve reading. And then, how about the others? Well, here at that stage, I'm going to focus my attention to this part of the projection. It is the second surface on the projection, second region on the projection. For the selected part of the object, that is the top view of that part of the object. And then, well, the question is the same. What is the shape of this feature? This is a rectangle, but this rectangle is the image of which feature? Feature is in which shape? Okay, how it can be answered? Method is transfer line following method. Well, say that now the transfer lines. Well, I selected top view. On the top view, say that this is the selected part of the projection. And then, well, introduce on the exam sheet by drawing the transfer lines passing through the limiting points. This is one of the transfer lines, and this is the other. Well, use the transfer lines passing through the limiting points. Okay? At the boundaries, extreme points. Well, you see top side view of the selected part of the object is between this and that. Those transfer lines. Since the x-axis is the same axis and it is used not only by top but also the front side view, well, the front view of this part of the object is to be between the same transfer lines, where at the region over here, over there, I have the front view. Between this and that is the top side, and between this and that, the corresponding part of the projection is this one. Over there you see there is one more rectangle. Rectangle on the top view, rectangle on the front side view. But do not say that it's a rectangular prism. Why? Because we have one more view. Okay, without referring to the third view, the other side view, without referring all the views, okay, do not say anything on the shape. Well, mitral line. It is over here, and then deal with the rest. This is the top side view of the selected part of the object, and so, well, introduce the transfer lines. Well, passing through the limiting points. This is one of them, and this is the other. Yes, you see my method. Deeply use transfer lines. the top view is between this and that, so the left side view must be between the continuation of those, where after this intersection follow this transfer line, okay, and that transfer line. Top view is between this and that. Left side view must be between the continuation of the same transfer lines, this and this. Well, what I mean, if you know the ABC of orthographic projection and you're aware that these are coordinate axis and mitral line, yes, is an inclined line. It uses, its inclination is 45 degrees and it is to use sine 45 degree is equal to cosine 45 degree. Well, can certainly say that the left side view, to find the left side view of this part of the object, okay, this part of the object is to see the left side view of this part of the object. The correct region to have a look at is not this region. It is the region bounded by this and that, those transfer lines. Those transfer lines are to transfer the delta y value from here to there. Since the y-axis here and there used by both of the same views, then the left side view must be between this and that. It is a must. So, well, here in this region, sure that need to find the left side view. For being sure that which part of the region corresponds to the image of is the region to find the image of the selected feature. Okay, then you know this is the front view, so follow the transfer lines passing through the front view of this selected part of the object. Okay, these are the transfer lines. Okay, yes. Since the front view is between this transfer line and that transfer line, and z-axis is commonly used, then the left side view must be between the same transfer lines, this and that. And top view is between this and this, so left side view must be between this and that. So, well, obvious that the left side view of this object, yes, must be over there within the region bounded by those transfer lines. You see, within this region, the corresponding figure is a triangle. Yes. Can you see in the region, okay, which is bounded by those transfer lines, I found a triangle. This triangle. So, well, this is the left side view of this part of the object. That is the top view. That is the left side view. That is the top view. This part of the projection is the front view of the feature. On the front view, I have a rectangle. On the top view, a rectangle. But on the left side view, corresponding part of the projection where I must have the left side view, you see, there is a triangle. So, well, when I perceive that the left side view is a triangle, so I must say that that feature, the second combined feature of the object, which I selected in this order and passing through the reading stage, is a triangular prism. Okay, it is a triangular prism. Yes. And then gather the dimensions. Okay, the geometry is triangular prism. Where it is? Well, see this dimension on the front view. Well, this corner, let's say point A for instance, for this corner, altitude is 8 millimeters relative to the edge of the bottom side surface. This line, you know, this line corresponds to the front view of the bottom side surface. Here is the model of the feature of the object, and that is the bottom side surface. While we're observing the object in this direction, we see the front view of the bottom side surface to its edge. Okay, this line is the edge view of the bottom side surface. This line is the front view of the right side surface. Okay, and this is the left side surface, and observing the body in this direction, we see the front side view. We have the front side view, and this line is the front view of the left side surface. This surface. How about the front view of the top side surface? While we're observing the object in this direction and output the front view, we see the top side surface of the object as such a straight line. It is the edge view of the top side surface. Okay, so here 8 millimeters for this corner is the altitude value relative to bottom side. And 8 millimeters, this line is the front view of the left side surface, is the location dimension for the same corner relative to the left side surface. And 15 here is the height of the second feature of the object. Okay. And on the top side view, I see that the width of that part is 10. And well, I concluded that this triangle on the left side view say is the left side view of the second feature of the object, and here 12 is the depth of the feature, depth of the triangular prism. Okay, you see, reading means not only on geometry but also on the size. Where is the feature? 8, 8, these are location dimensions. Okay, the others, 10 is the width, 15 is the height, 12 is the depth. Okay, now the base of the triangular prism is over the front side surface. So in this regard, I'm going to take a sketch right on the front side surface. Left click, right click, and then say new sketch. Now sketch plane is coinciding onto with the front side surface, and then to be able to create the triangular prism, first I'm going to have a rectangular prismatic extension and then chop it as symmetric portion, chop it as half. Well, create a rectangle here. My consideration is the base of triangular prism. And then dimensional constraint, project geometry process, apply, have the image of this boundary. Which boundary? This boundary of the surface. Have the image of the bottom side surface. Edge of the bottom side surface. Why? To have the shoulders to input the dimensional constraints. Clicked on this one and then say that from the bottom side boundary of this rectangle, in my consideration it is the base of the triangular prism which is over the front side surface, to the edge of the bottom side surface distance from the given engineering drawing, I know that it is 8. Okay. The other coordinate, it is with respect to the left side surface for the same corner, is also 8. Yes, I mean this dimension. Okay, for the corner 8 millimeters is the other coordinate. So well, sorry, here solid model sketch mode, from here to there distance is 8. Height of the prism, the second feature, is 15. Okay, and then width of the prism is, as it is shown on the top view, 10. Okay, so here from here to there distance is equal to 10. So this sketch is correct in shape and in size. Also, it is at the correct place. Finish the sketching stage and apply extrusion process. From the given left side view, where it is, here is the left side view, I see that it is 12. Okay, so extrusion length is 12. And then say OK. Okay, well, after adding this feature, although I know that it's a triangular prism, but here at that stage, you see I created the feature as a rectangular prism. Save this solid model file and then see the magic. Since the Inventor is a sensitive software, okay, when you update the solid model, then already created views will automatically be up-to-dated. And then yes, on the top view, I have a rectangle, on the front view rectangle, but front and the top view, you see, not consistent with the given view. On the left side view, I have a rectangle. This means here, since I couldn't find the same projection as it is shown or given on the exam sheet, this means my reading at that stage is not correct yet. Actually, perceiving that the left side is a triangular triangle, I have already concluded that it must be a triangular prism. But at that stage, I created, for my convenience, although I know that it's a triangular prism, I created a rectangular prism. And then, well, take a sketch right over this profile surface, and then project geometry process, have the projection of this edge, have the projection of this edge of the surface, and then this edge, and then draw this diagonal. Snap this characteristic point. Cursor can snap, that characteristic point also can snap cursor. So I added this sketch. Well, this sketch and the projected boundaries of the selected surface, I mean this boundary and that boundary, you see forming a triangle. Finish the sketching stage and apply extrusion process. Show this profile but in cutting mode. Cut the material. Yes, my method. Since at the beginning I created a rectangular prism and then, well, drawing the diagonal of the profile surface and just applying extrusion process in cutting mode, without using work plane, I achieved to locate this prism at such an intermediate cross section. If at the beginning attempt to draw the triangle and extrude in this sense, then this means you need to use what? A work plane. At that cross section, have the work plane, and on the work plane, draw the sketch. It takes a greater time. So, well, use my method. What I did, I created the rectangular prism, although I know that it is a triangular prism, and then, well, thereafter, over the surface, drag this diagonal and applying the extrusion process in cutting mode, using the half of the surface as the region, cut the material and converted rectangular prism to triangular prism. Okay, update the file, clicking on Save button, and then have a look at whether now the views you already created are now automatically corrected. Yes, you see, if after the reading stage, after achieving reading for the first feature, you create the views, then while you're adding the other features in the model, on behalf of you, the program Inventor can add the images of the newly created ones. So, well, you see, drawing part is achieved by the software. Well, what I did, I added this triangular prism in the model, and the images of this feature have automatically been created and the views correspondingly modified by the software. And also, well, this is my method, yeah. Well, I'm creating the solid model and the necessary orthographic views almost simultaneously. And since I'm creating the orthographic views just after creating the model, well, can clearly see whether my reading is correct in shape, and thereafter showing the dimensions, can say that in size as well. Okay, then how about dimensions? Show the dimensions. Well, these are the dimensions to show: 8, 8, 15, top view 10, and the left side view 12. Check whether for my reading for this corresponding images dimensions are the same. Geometry is correct: rectangle, rectangle, triangle. Then the views are okay and consistent. How about dimensions? Since I'm going to show a smaller dimension, I need to have more space, so hold this dimension and dragging increase the space between this and the boundary of the surface. Dimension, start the dimension showing stage process, clicking on this button, and then the coordinates from here to there. Distance, yes, check whether it is the same. It is the same, 8. From here to there, yes, whether it is the same. Yes, it is the same, 8. And the height, indicate this, well, do it again, I made a wrong click. Indicate this line and then check whether the height of the created feature is the same as it is shown on the exam sheet. 15, yes, on the exam sheet, have a look at, it is 15. And the depth, show it 12 on the left side view, with 10 on the top side view. Okay, top side view, check whether it is the same. Yes, it is the same, 10. Okay, clicked on OK button, and on the left side view, show the depth and then check whether you found the same number. It is the same. So shape of the feature in my reading correct. It's a triangular prism, and when I show the dimensions, I obtain the same dimensions, location and size dimensions. So my reading and also model creation are both correct in shape and in size. So for the second feature, can say that, yeah, great, I achieved the reading. Okay, save the file. I think you gather it, yeah, that is my method. And you see, well, my method, the first tool is transfer lines, the other tool is view creation. When I create the view, if I obtain the same view, the views as the same as they've been shown on the say the exam sheet, and when I show the dimensions, if I find the same values, can say that, okay, my reading is correct. If not, then think about it. Why? Which part is wrong? In shape or in size? Make another trial. Make one more guess. Say that it is not a rectangular prism, but it's a triangular prism, for instance. Okay. And then, on the view, select another feature. Which view? Since the top view is more clear, more understandable, you see I made the discretization on the top view. And now here, take a pen. In which color? Okay, green. And then, well, the thickness. Okay, this order say that. Yeah, well, here I focus the attention to this part. Okay, of the projection. This is the third feature. First feature, rectangular prism. Second feature, it is top view, is a triangular prism. And what about this one? Well, it is a rectangle, and you see there is a strong hint on this view. Longitudinal axis. Long dash, short dash. Can you see? Long dash, short dash. Yes, here. That is the line. Long dash, short dash. Make a zoom in. Long dash, short dash. So, well, this is to say that, it is a revolved feature. Check whether it is the image of a truncated cone or the image of a cylinder. Well, here that stage can say that you see this is an extension. And this is the top side view, and this line is the top view of the backside surface. Since this line is the top view of the backside surface, and this is an extended part, can say that, well, at the backside of the object, there is an extension. It's a revolved feature, but not say sure about it that it is a cylinder or it is a cone with a very little cone angle. Check it, which one is the case. How? Take a pen, now in red color, and then transfer lines. Draw this transfer line. Yes, draw this transfer line. The transfer lines passing through the limiting points. And then yes, the top view is between this transfer line and that transfer line. Since the x-axis is commonly used by front and the top, well, the front view of this feature must be between this and that. Over there, correspondingly, I see a circle. Yes, here. Just following the transfer line, this and that. Well, on the front view, I see, well, the region bounded by the same transfer lines. I see that there is a circle. It is a dashed circle. Yes, it must be a dashed circle because it is a feature at the back side of the main part. Yes. This line is the top view of the backside surface. So this extension is at the backside. Since it is backside, well, the main part is an obstacle for the visibility of that feature, while the observer observing the object in this direction. Well, it is a circle, but, well, to say that it is the image of a cylinder or image of a truncated cone, well, you should find the diameter. The diameter has been shown on which view? On the front view, you see, since it is hidden, you know the dimensioning rule. If the feature is hidden, well, here, find the the picture file with a clear, not this one, sorry, picture in picture format. Yes, here it is. Have the file with a clean, as a clean page, and then yes, well, follow the transfer lines to see where is the left side view. Okay, now select this tool and then take a pen. In which color? Say that this color. I selected the pen. The pen thickness, well, decrease the thickness. Okay, this size. And then Well, this is the transfer line passing through the limit of the front view of the feature, and this is the other transfer line. Since the front view is between this and that, it is left side view must be between this and that. So this part cannot be the left side view. This part cannot be the left side view. Left side view of the feature must be between this and that. Where it is? This is the mitral line. This is the top side view of the selected feature. And these are the transfer lines. This and that. Top view is between this and that. So left side view must be between the continuation of the same transfer lines. This and the other. So well, the region at the region bounded by this and that and this and the other. Yes, sure, this region we have the left side view of the selected feature. And on the left side view, you see, the dimension has been shown using a leader line. Technical note, it says that diameter is 10. Yes, diameter is 10. Can you see? It is written. Diameter is 10. And as the size of this feature, we have only one diameter value. So conclude that it is a cylinder. Cylinder is at the back side, okay, of the main part of the object. Its diameter is 10. How about the location dimensions? On the top view, here, you see, well, one of the location dimension has been shown for the longitudinal axis. 20 is the location dimension. It has been shown for the longitudinal axis with respect to right side surface. Well, on the top view, this full line corresponds to the edge of the right side surface. Yes, see the model. Right side surface is over there. On the top view, while observing the body in this direction, we see the edge of the top view of the right side surface to its edge. This line actually is the top view of what? The right side surface. Also, it is the top view of this intersection. It is the top view of that intersection. Yes. And the location dimension here has been shown with respect to the right side surface, 20 millimeters. The other location dimension has been shown here, 18 millimeters. It is with respect to the bottom side surface, 18. Note that this full line is the left side view of the bottom side surface. And relative to this, location dimension for the longitudinal axis is 18. Yes. And finally, the depth of the cylinder, length of the cylindrical extension is 14. Okay, now knowing these values and knowing that the feature number 3 is a cylinder and its base is at the back side surface of the main part, let us create this model. Okay, it is at the back side. Well, I already said that this is the front side, so see the back side of the body. Yes, this is the back side. Take a sketch right over the back side. Okay, and I know that the feature is a cylindrical extension, so its base is over the back side and its base is a circle. So create a circle as the necessary sketch, and then, well, locate it. Anchoring stage. Sketch method is modern method, you know. In Inventor, it is the only method. Project geometry button. Start the process and have the projection of this boundary. Have the projection of that boundary. Why those boundaries? Because on the exam sheet, I see the location dimension. One of them is with respect to the edge of right side. With respect to other, with respect to the bottom side. 20 18, and the diameter is 10. 20 is the coordinate, 18 is the other coordinate. Okay, then location dimension. From the edge of the right side to the center, distance is 20. Okay? Actually, I forgot the other dimension. Have a look at. Bottom side to the axis, 18. Okay. This is the edge of the bottom side, and this is the center of the circle, and the distance is 18. Am I true? Yes, 18. And the size of the circle corresponds to the size of diameter of the cylinder. It is 10. Okay. So well indicated, and diameter is 10. That is the sketch. Correct place, and it is correct in size. Finish the sketching stage and apply extrusion process. Extrusion length, on the left side view it is shown 14. Okay. Apply extrusion process, show this profile. Extrusion length is 14. And then say OK. Yes. Here is the object. Rectangular prism is the main part. At the front side there is a triangular prismatic extension. At the back side, cylindrical extension. Save this file and then check. Well, I am sure the orthographic views have been updated by the software, and gonna find the images of the newly added feature. Yes, it is true. You see, on behalf of me, inventor, while I am modifying the solid model, inventor, creating the images of the newly added ones. So that is my technique. Okay, and while I am having the images of the newly added features, and also can see that my reading is correct. If I obtain the images as they have been given on the exam sheet, then can ensure that my reading is correct. Now, after having the images of the newly added one, then without forgetting, make the necessary highlighting. To say that on the top view the rectangle is not the image of a rectangular or triangular prism, but it is the image of a revolved feature, you know, we must show the longitudinal axis. I clicked on this and then show the surface limit lines. And then yes, between them have the longitudinal axis, and this is the left side view of that feature, and since the feature is a cylinder, then show the longitudinal axis for highlighting. And this hidden circle, yes, it is a full circle. It is the front view of the cylindrical extension. It requires horizontal vertical axis. Clicked on this button and then show the circle. Have the axis. And then the dimension, whether the size of the feature is correct, and whether the feature which you created it as model is at the correct place. Show the dimensions. While showing the dimensions, what I am doing, I am completing the projections and also checking whether my reading is correct in size. Okay, show this, show the longitudinal axis, and then drag the mouse. And then check whether the location dimension is the same. Yes, it is, as it is shown on the exam sheet, the same, 20. Yes. The altitude has been shown on the left side view, depth on the left side view, and diameter on the left side view. Okay, then, well, check whether gonna have. Indicate this, and then, yes, 14 is the length. It is correct. Okay, altitude with respect to bottom side surface. The location dimension for the longitudinal is 18. Is it the same value? Yes, 18. Okay, and diameter is 10. Well, indicate this age of the surface of the cylinder, and then yes, inventor saying that it is 10, and the necessary diameter symbol is preceding. But if I indicate this dimension over here, you see axis extension line will cross the dimension. It is not allowed. It's a strict rule. Avoid having intersections along dimension lines. If I show the dimension over here, then its extension will cross the other dimension line. Well, you know, it is a violation. Well, show the shorter dimension first, longer later. But either I obey to the rule and show the shorter distance first or later. Both of the cases going to have a violation. Dimension, one of the dimension line will intersect by one of the extension lines. So, well, do not use dimensioning technique, but use leader line technique. Click on leader text button and then indicate the extension at a point along its surface limit, and as it is shown on the exam sheet, left click, right click, and say continue. And then in this dialog box, show the diameter. Okay, well, from here, select diameter symbol and then write the diameter 10 and then say OK. Yes, 10. You see this dimension, well, as it is shown on the given view. So, well, yes, my reading is correct on the third feature as well. So, save the file. One more time, this drawing file, and I think I have already saved the solid model file. And then yes, turn back to the exam sheet, and then on the top view, you know, already I have already made the discretization, and here the other discretized region on the view, I'm going to select it, this region. Okay, here it is a hidden rectangle. Okay. For this hidden rectangle, which part of the projection corresponds on the front view? Okay. Take a pen. Let me take blue. Okay, and then draw the transfer lines. Okay, the transfer lines are to pass through extreme point. Follow this transfer line, sorry, this one. Well, do it again. Well, couldn't draw it correctly. Well, this is the transfer line, it passes through the limiting point. Couldn't do. Do it again. Actually, yes, the limiting point is this one, and then follow this path, transfer line, and then the other transfer line passing through the other limiting. These are straight lines, but here I'm using an ordinary mouse, so I'm not so good on drawing those. How about this one? If I try to use this tool, first erase these lines and then try to use this one. Well, I took blue, decrease the thickness, and then yes, limiting point, this is the passing, the transfer, it passes through the limiting. This is the other transfer line. Okay, and well, top view is between this and that, it's a hidden rectangle, and the front view, I found this rectangle. In the region, it is bounded by the same transfer lines. Rectangle, rectangle. Okay, mitral line is over here. and then draw this transfer line. Sorry, this transfer line. Draw that transfer line. Okay, and the transfer lines, this and that. Actually, I'm not so good on drawing the transfer lines straight. Well, have the file in paint environment. Yes. And then, yeah, I decided to explain the things for this feature in paint environment. Yes. Transfer lines, line thickness, say that this one. Okay. Well, this is the top view of the selected part of the projection. On the top view, this is the top view of the selected part of the object. It is a region. It is a hidden rectangle. Since it is not in the atmosphere, I am sure that it is a cavity, empty space, because this is the image of a single component, and I know that the main part is a solid part. So within the solid part, impossible to have another solid feature. This is hidden, so this means it must be an empty space. But which kind? Okay, transfer line. One of them is passing through the extreme point. Okay, and the other one is passing through the other extreme point. Okay, well, these are the transfer lines, just bounding the top view and the front side view. Okay, top view is between this and that, so front view must be between the same transfer lines, this and that. Here I see there is a rectangle, visible rectangle. How about the left side view? Where is the left side view? Well, this is the transfer line passing through the limiting point. Okay, this is the other transfer line passing through the other limiting point. Well, the front view is between this transfer line and that transfer line. So the left side view must be between the same transfer lines. Whether this part is the left side, this part left side, this part, which part left side? The answer comes from the coordinate transferring from the top side. Okay, this is one of the transfer line passing to the limiting point. Okay, this is the other transfer line. You see, top view is between this and the other. So the left side view must be between the same transfer lines. I mean between this and that one. Following this transfer lines and the others as well, you see I found the region which is bounded by those transfer lines, and in this region I am sure I must find the left side view of that feature. Okay, what I have over there, left side, as the left side view. Well, here answer the question. Over there I found another rectangle. Well, it would be hidden if there were no broken out section. Here you see the meaning of this break line and the equal spaced hatching lines. This part is a partially shown sectional view, broken out section. This broken out section is to have the image of that hidden feature as if visible. It is required to be able to show the depth of that cavity. Well, if it were hidden, not as if visible thanks to the broken out sectioning, if it were hidden, then well, showing this dimension would be a violation. To be able to show the dimension of hidden features, you know, if it is the only view to show the dimension, then instead of drawing or creating the view normally, we create the view as sectional. Here it is a partial sectioning. Thanks to this partial sectioning, we have the image of that cavity as if visible. But here, well, at the end, I concluded that on the top view a rectangle hidden, on the front view a visible rectangle, on the left side view a rectangle. So can say that that feature, fourth feature, is a rectangular prism. After saying rectangular prism, then, well, see the dimensions. Location dimension for the corner of that rectangular cavity is 25, and the other location dimension is 12. And you see, it starts from the edge of the front side surface of the main part of the object, which is a rectangular prism. So, well, since it is starting from the front side of the main feature, well, to be able to create this model, take a sketch right over the surface, front side surface of the main part, and then after drawing a rectangle, apply extrusion process and empty the inside. Create a rectangular prismatic cavity. Well, the width of the prismatic cavity is 15, height of the cavity is 10. Location dimensions 25 and 12. Okay. Create the model. The depth of the cavity is 4. Okay. Take a sketch right over the front side surface because I concluded that that empty space starts from the front side of the rectangular prism. Create as the necessary sketch. In my mind, it is the rectangle. It corresponds to the edge of the cavity on the front side surface. And then for this sketch, input the constraints, dimensional constraints. Yes. For the corner of the rectangle, 25 is the location. It is with respect to left side surface. Okay, this is the edge of the left side surface. Apply the projection process, have it as image. Okay, and then, well, have the image of the edge of the bottom side surface, and then dimensional constraint. From here to the corner, distance is, of course, arbitrary in value, but the correct value is 25. Okay, 25. Yes. The altitude for the bottom edge is equal to 12. So write 12 input. Okay, width of the cavity is 15, height is 10. Width is 15, height is 10. Yes, sketch is at the correct place and in the correct size. And this sketch, in my mind, corresponding to the edge of the rectangular cavity, okay, which is on the front side surface. Finish the sketching stage and then apply the extrusion process for emptying the inside. Okay, apply the process in cutting mode. How about the cutting depth? From the left side view, I already found the value. I have already found the value. It is 4. And then say OK. Yes. Created the model of that feature. And then save the file. And then check whether the automatically created images are the same as they are given, as they are shown on the projections. Yes. On the front view, I obtain, as it is top view, a hidden rectangle. On the front view, a visible rectangle. And on the left side view, hidden rectangle. But on the exam sheet, repeat again, this rectangle is partially visible, partially hidden. Well, it is as if visible thanks to the existence of the broken out section. Okay? Well, I'm going to create the broken out sectional view. This part make the image as if broken. After creating the model of that model of the object, it corresponds to this part of the projection. Okay? Well, I don't want to create the broken out sectional view at this stage. But, well, check the dimensions, whether the location and size dimensions are the same. From here to this boundary, dimension, you know, is 25. Yes. Is it correct? As it is the same as it is shown? Yes, 25. And the altitude for the bottom edge of the cavity is 12. Okay, check whether it is the same. From bottom edge to the bottom side surface, distance is 12. Yes. By the way, if the space while you're adding the dimensions of the newly created ones are not sufficient, then yes, you can slide to already shown dimensions to make the space larger to show the dimensions of the newly added ones. You can edit. If the space is not sufficient, then well, slide the views. For instance, hold the base view and then dragging it, make the distance between them larger to show the dimensions of the newly added ones. Okay, the height of the cavity, show it on the front view from here to there. Yes, it is as it is shown 10. And the cavity, although cannot be shown, shouldn't be shown on the left side view at this stage because it is hidden. But just to check whether it is 4. Yes, it is 4. But don't show this dimension here. After creating the broken out section, show it. Okay. The width. Show the width. Clicked on this and then width of the cavity. It is 15. Yes, true. 15. It has been shown here. Why? Because, well, after adding this feature, well, if we show the dimension not here but there, you see the dimensions will interfere to their intersect. Extension line intersect the dimensioning line. So, well, on this view, perceiving that in future it's going to be like that, well, delete this dimension and then show it not between the views but say above the front view there. Otherwise, following stage, this dimension would clash with the other. Yes. Save this file. And then continue. Well, on the sheet, where is the sheet? Okay, here. There is another region. Actually, close this file. Without saving. And then open it again. Close this one. Paint. Open the file in Paint environment. Here is the file. And then Well, the other region on the top view, it is distinguishable, is this part. There is a circle over here. Okay, then check. That circle corresponds to where? Follow the transfer lines. This is one of the transfer line which is passing through the limiting point. This is the other transfer line passing through the other limit. And between the transfer lines, this and that, on the front view, I see there is a hidden rectangle with longitudinal axis. Well, on the top view, it is a circle. On the front view, there is a hidden rectangle. And when I follow the transfer lines, this transfer line and that transfer line, and also this of course together with the mitral line, okay, and the continuation of those transfer lines, I see that the left side view, to find the left side view, this is the region. This region, I see there is one more hidden rectangle with longitudinal axis. Sure that it is a revolved feature, but well, to say that it is a hole, well, change the order and first answer this question. Why there is such a hidden rectangle on the top view? Okay, this hidden rectangle. Well, first achieve reading for this part of the projection. On the top view, there is a hidden rectangle. Follow this transfer line. And the other. Yes, between this and that, there is a rectangle on the top view. It is hidden. And between the same transfer lines, this and that, on the front view, I see there is one more hidden rectangle. See this hidden rectangle. Make a zoom in. And then see. Sorry. Pen. Yeah. Yes, see this hidden rectangle. Hidden. Okay, this rectangle. It starts from here and then reach to there. And then you see it is a horizontal hidden line, and then the rest is vertical. Well, thanks to the existence of this broken out section, this part of that line is as if visible. So on the top view, there is a hidden rectangle. This hidden rectangle on the front view corresponds to another hidden rectangle, but that hidden rectangle starts from the edge of the bottom side surface. And then when I refer to the left side view, how? Of course, by using the transfer lines. Where is the mitral line? Mitral line is over here. And this is the transfer line passing through the limit of limiting points of the hidden rectangle. And this is the other transfer line passing through the limiting points of the selected part of the projection. And well, following the continuation of those transfer lines here and there, can see that well, in the region bounded by those transfer lines, I have another rectangle. Well, if it were say simply created left side view, then it would be completely hidden rectangle. But since here you see there is a broken out section, this part of the projection of that feature is as if visible. Can you see? This part is visible. thanks to the existence of this partial breaking. You know what is broken out section and how it is created. So this stage, it is my conclusion. Within the biggest part of the object, there is a hidden, there is a rectangular prismatic empty space. Okay? And then, gather the dimensions. The location dimension for the profile surface of this cavity is 10. Well, here actually showing this dimension is a violation, although this part is hidden. But there, thanks to the broken out section, the wall of the cavity, it is as if visible. This is a sectional part, and the wall thickness is 10. On the left side view, for this empty space, you can say that walls. The wall thickness at the left side wall is 10. Right side wall is 10. Back side wall is 7. Front side wall is 7. And this dimension, since this part is as if visible, it is legal, it is allowable. 20 is the height of the cavity, the location dimension for the ceiling surface. Okay, now since the dashed line starts from the edge of bottom side surface, I conclude that that empty space starts from bottom side. So to be able to create this model, yes, take a sketch right on the bottom side surface, that is the bottom side. Left click, right click, new sketch. Okay. And then create a rectangle. Since the cavity is a rectangular prism, the edge of the surface of the prism will be a rectangle. And then dimensional constraint. Obtain the image of this, have the image of this, have the image of this, have the image of this. And then relative to the projected boundaries, input the wall thickness. Okay, the location dimension for this line, in my consideration, this line corresponds to the edge of the, the profile surface of the cavity is 10. The other one also 10. Okay. And with respect to back side, with respect to front side, wall thickness is wall thicknesses are 7. Okay, 10 and 7. So this dimension is 10. This constraint. From here to there, it is also 10. Okay. This is the edge of the front side surface. I am sure. Edge of front side surface. From the front side surface of the main part to the edge of the frontal surface of the cavity, distance is 7. And this is the edge of the back side surface of the main part, and this is the edge of the other frontal surface of the cavity. From the left side view, I know that this dimension is also 7. Okay, well, you see, inputting the wall thicknesses, I fix the size of the sketch. Finish the sketching stage and apply extrusion process. Extrusion length from this image, I see that 20. From the bottom side surface to the deeper part of the prism, the cavity extends, its height is 20. So apply extrusion process in cutting mode. Show this profile. Okay, apply the process, selecting this one, teach to the software that your purpose is to cut, and cutting value is 20. And then say OK. Yes. Save the file, update it, and then check whether the orthographic views as they are shown on the exam sheet. Yes, on the top view, hidden rectangle. That is the exam sheet. Okay, see whether it is the same. Yes, hidden rectangle. And front view hidden rectangle, check. Yes, on the front view there is a hidden rectangle correspondingly, and left side view hidden rectangle. If there were broken out sectional views, sections on the views, then I would have the image of this cavity partially as if visible, like this, like that. Okay. Well, quickly check whether the dimensions are as correct as they are shown. From here to there, yes, 10, but do not show because it is hidden. Reclick. From here to there, yes, it is 10. And the other dimensions, well, the backside wall thickness I see 7, correct. Okay. And the front side wall is 7, yes, 7. This means score, but do not show because the on the views that feature is hidden. After creating the broken out sectional views, then I'm going to show it as dimensions. Okay, save this file. And then, in the order, think about it. Why there is such a circle? Already answered the question. Following the transfer lines, I concluded that there is a hole. It starts from the top side and opens to the inside of the body. Within the main part of the body, there is a rectangular prismatic empty space, and the hole extends to that space. While the location dimension for the hole, 30 by 18. Well, 30 is the location dimension with respect to the left side surface. 18 is with respect to the back side. This is the top view, and this line is the edge of back side. This line is the edge of the right side. Okay, location dimensions. On the top view, as the size of the hole, you see this annotation says that diameter is 12. And along the annotation, we have the diameter only. This means hole is a truly extending hole. It is not a blind hole. It's a simple hole, and whatever the thickness of the part where the hole exists is, then the length of the hole is the same. Okay. Create the hole. How? Applying hole creation process. Location dimensions 30, 18. Okay, keep in mind. And then, well, start hole creation process. Hole starts from the top side surface, so indicate the top side. Okay, the hole diameter 12. Location dimensions 30 and 18. Okay. So into this box write 12. Okay, I selected this one. It is a customized hole, not a standard hole. Otherwise, I would click on this button, you know. It is not a contour bore hole. Otherwise, I would click on this button. Diameter is 12. The location dimensions. Well, with respect to the edge of right side surface, location dimension is 30. Okay. And relative to the other reference, well, see, it is 18. So 18 into the box. And then it is truly extending. Yes, I selected true all option. I know that there is no solid feature in front of this hole, so can say truly cut the material. Okay. And then say, clicked on OK button. Here is the hole I created. You see it starts from the top side and extends to the surface of the ceiling, to the inside. Okay, save the model and then check whether found the images as they are shown on the exam sheet. Yes, on the top view a circle, On the front view, hidden rectangle. On the left side view, hidden rectangle. Now highlight that these hidden rectangles are the images of a whole. How? Longitudinal axis. Show the longitudinal axis. Clicked on this and then show this limit, show that limit, have the axis. Show this limit, show that limit, have the axis. Okay? And on the top view, it's a full circle. It requires horizontal, vertical axis. Yes. Show the location dimensions for this circle. On this view, it is 30. From here to there, distance is 18. You see, I located this dimension measuring 10 millimeters with respect to the outmost boundary. This outmost boundary is this one. So the distance between this dimension line and the projection is relative to the outmost boundary 10 millimeters. Okay, if you show the dimension measuring 10 millimeters from the other boundary, it is going to be wrong. Well, the outmost boundary is the projection of the cylindrical extension, has the outmost boundary, this one. Relative to here, go 10 millimeters away to locate this dimension. Remind you on such format requirements. Okay, and show the diameter. Yeah, so clicked on this and then show the diameter. Here it is 12. Save the files. And then now relatively more difficult part of the object. Well, on the top view, the other region is this hidden rectangle. Okay, take a pen and then check what it is. You see here there is a hidden rectangle bounded. I mean this hidden rectangle. Increase the line thickness. Well, this part of the projection. There is a hidden rectangle here. On the top view, it is hidden. It is a rectangle. Follow the transfer lines. Okay. This transfer line, well, it is to pass through the limiting points. This transfer line corresponding to this visible line. Well, it is as if visible because there is a broken out section and the rest is hidden. Okay. Well, the other transfer line is passing through the other boundary. And you see between this and that, there is a rectangle on the top view. Between the same transfer lines, okay, another rectangle. But that rectangle, little bit increase the image. You see that rectangle. Yes, well, careful look at, well, ends over there. Well, that rectangle partially visible as if the rest is hidden, and then, well, you see after this corner, the rest of the rectangle, the rest of the projection is a horizontal hidden line. And then, well, we have one more hidden line here. Okay. Well, front view a rectangle, top view a rectangle. How about the left side view? Okay. Draw the mitral line. Its inclination is 45, and then, well, the top view is between this and that. Sorry. The limiting point is here, over there. Okay. Well, the left side view must be well, between the transfer lines. These are the continuation of those. Okay. Yes. Now between this and that, and here this line, transfer line, corresponds to the transfer line passing to the limiting points of the front view of that feature. I see in this region there is a circle arc. Well, rectangle, but here there is a circle arc. This means it is not a rectangular prism, but it is a semi-cylinder. Well, from the top view, I see that semi-cylinder, well, erase and then make zoom in. That semi-cylinder you see is extending, well, within the rectangular empty space. So, well, this part is an empty space. Within an empty space cannot have another empty space. Impossible, because it is not an assembly. It is a single component. So within a solid part cannot have another solid feature. Within an empty feature, empty space, cannot have another empty space. So, well, this rectangle actually is the image of a semi-cylinder, is a solid extension. It is in semi-cylindrical shape. Okay. Well, within the body there is a semi-cylindrical extension. It starts from the profile surface of the rectangular cavity and extends 25 millimeters with respect to the right side surface. 25 minus 10, this means the length of that cylindrical extension is 15 millimeters. Well, the semi-cylinder, the symmetry axis of the semi-cylinder with respect to the front side surface of the main part is 18. Can you see this dimension 18? Or here, this is the completed projection. Show this dimension. The symmetry axis of this semi-cylindrical extension is 18 millimeters away. And the longitudinal axis of the semi-cylinder, 10 millimeters away. Okay. Semi-cylinder radius is 6 millimeters. Okay. Here need to make a calculation at the sketching stage to locate the sketch over the surface. Well, 18 minus 7, sorry, 18 minus 7 makes 11. 11 minus 6, well, the distance from here to there, this means is equal to 5. Okay, now, after saying that there is a semi-cylindrical extension, try to create this model. Well, you know, to create the model of a semi-cylinder, it is my method. First, in the maximum size, I create a rectangular prism and rounding the edges, sharp edges, convert the shape from rectangular prism to semi-cylinder. So the rectangular prism, for having the rectangular prism in the maximum size, well, the dimensions 10 plus 6, 16 is the height. Okay, 12 is the depth, and the distance from this surface to that surface is 5. Well, unfortunately, probably I'm going to forget these numbers. But say, okay, first take a sketch, right? Okay, on the surface where I have the base of semi-cylinder. I see that this surface is the surface, the base of semi-cylinder extension is over that surface. So indicate the surface, left click, right click, and new sketch. Take a sketch, right? And then, well, try to draw the base of the rectangular prism over the surface. Well, if the sketch plane is behind of an obstacle, you see, solid part, this frontal part is an obstacle for the visibility of the sketch. What can you do? To be able to allow yourself to see the sketch while you're drawing, okay, well, change the visualization style. It is one of the method. View from shaded solid realistic appearance to wireframe. Then after changing the visualization style to wireframe, you see the sketch because the obstacle will be transparent, as if made of banded wire. Or, well, yes, to be able to see the sketch on the sketch plane. Sketch plane is behind of such a solid part. Well, in Inventor, along the status bar, there is such a facility to use. If you find this button, okay, and clicked on it, see the changing in the screen. Well, the part which is the obstacle for the visibility of the sketch will disappear from the screen. Okay? Yes, this is a recommended technique. Clicked on this button and then take the visibility of the obstacle from the screen. And then, well, draw the sketch. Project in sketch mode, of course. Clicked on sketch button. Project geometry. Have the projection of this edge. Okay. And then using the projection of that edge can draw the sketch. Okay. Create a rectangle first arbitrarily. Tilt it and then little bit as lighter illuminated C. And then for this rectangle, well, here there is one more projection process. Have the projection of this edge and then trim the further extensions, this, and that. And then size the rectangle. Location dimensions. Well, this boundary of the base, well, from this limit, it is the edge of the front side surface of the main part, is equal to 18 minus 6. What? 18 minus 6, 6 is the radius, 12 millimeters. Okay. Input this constraint, dimensional constraint. Yes. Dimension. From the projected boundary to the boundary of the sketch, it is 12. Okay. Well, the radius of the semi-cylinder is 6, so the depth of this sketch is to be 12. Okay. Well, the altitude of the axis of the semi-cylinder is 10 plus 6, so height of the semi-cylinder is 16. So here, well, for this rectangle, the size is 16. Okay. finish the sketching stage, and then apply extrusion process. The profile is at the correct place. Okay. The extrusion length from the front view can be seen. 25 minus wall thickness is the length of the semi-cylinder. It is 15. So here, apply extrusion process. Okay. The length of the extension is 15. And then say OK. And then, well, convert this rectangular prism to semi-cylinder. See how? Applying filleting process, of course. Radius is 6. And then indicate this H. Indicate that H. And then say OK. Now you see it is a semi-cylinder. I corrected it as geometry. This is my method. Okay, save this file. And then check whether on the already created views, well, the up-to-date version includes the images of the semi-cylinder. Yes, on the left side view, I have it as image. On the front view, a hidden rectangle corresponds to the front view of that semi-cylinder. And the top view, rectangular prism. That's a rectangle. Show the longitudinal axis to say that it is a semi-cylinder. Okay. On the view, left side view, show the horizontal vertical axis. Okay. And then the last feature to deal. Yes. You see on the top view, there is a hidden rectangle. Well, the longitudinal axis extending from the beginning to the end of this rectangle says that it is a revolved feature. Well, if we have a look at the front view, can see another rectangle with the longitudinal axis. And, well, on the left side view, this hidden rectangles corresponds to this circle. So no doubt, well, within the semi-cylinder, there is a coaxial drill. Drill diameter is 6. Okay, then let us create it. It is coaxial. Yes, hole starts from the surface of the cylinder and it is coaxial. Hole creation process. Okay, it is truly extending. Diameter is 6. Okay, so into this box write 6 and then indicate the starting surface and then say that this hole is coaxial with the cylinder, semi-cylinder. How you can teach to the software that it is coaxial? Just indicate the edge of the other feature. Then inventor will shift the hole to the place where it is gonna be coaxial and then say OK. Yes, created the hole and then yes, that is the edge of the hole on the right side surface and then see the images. Yes, on the top view I have the image as it is shown on the sheet. Well, here on the left side view the hole, yes it is. Extend this longitudinal axis, stretch it. And on the front view show the longitudinal axis. Yes. And then, yeah, my reading is okay. Finish the reading stage. Save the file. You see, I managed to obtain the same projections. Well, my reading is correct. That is the object. By the way, make it solid model. It is just still model of the object. To be able to make it solid model, assign the material. Whether we know the material of the object at the title block, well, there is no info because the title block, as I mentioned at the beginning, has not been completed yet. Here say that it is made of aluminum 6061. Okay. Well, for this object, assign the material, clicked, right click, assign to selection, and then close this dialog box. It is made of aluminum alloy, so it is the solid model of the object. Save the file, and then, well, now the time to show the parts for which we have dimensions to show as if visible. How? Applying broken out sectioning. Need to show the wall thickness here, need to show wall thickness there. Okay, but the edge of the inner surface of the wall is hidden. If it is hidden, then you know, dimensioning rule says that don't show the dimension. So, well, to be able to show the dimensions, we need to show this part as if visible. Well, broken out section, I mean, try to have this broken out section, and then can show this wall thickness. You know the procedure. First, indicate the view, don't forget, with a click, on which you're going to have the part of the image as if broken. And then click on Start Sketch button. Yes. And then, you know, the region where the part of the projection is shown as if the object were broken, we use a wavy boundary line. It's a thin wavy line. It is called break line. To be able to have the break line, drop this list, and from the list select spline option. And then, well, try to draw the boundary line. Okay? Yes. Well, creating the boundary, avoid having sharp direction changing. For instance, such a changing is very sharp and it is a discontinuity. Going to be a discontinuity. If inventor cannot calculate the derivative along the boundary line at any point, all the points, because of sharp direction changing, because of the discontinuities, then cannot create the broken out section. So draw the boundary break line smooth enough. And don't forget to indicate the first point one more time, because in sketch mode the boundary must be a closed boundary. Finish the sketching stage, and then apply this process. Place view breakout. Clicked on this, start the process, and indicate the same view. Well, in the dialog box, well, you're going to create the broken out section for having which part of the projection as if visible. Yeah, answer this question. My purpose is to indicate this part of the projection as if visible. So, well, wall thickness, I need to show the wall thickness. I'm going to show this part. Okay. Indicate this hidden line with a click and then say OK. Then the rest is achieved. This part will be shown as if visible. So after having that part of the projection as sectional, okay, then can show the dimension over there, annotation, dimension, wall thickness. can be shown here. It is now allowable because the image is as if visible. Well, to be able to show this wall thickness, do the same thing. One more broken out section. But before creating the other broken out section, well, correct this mistake. You see, inventor creates the break lines with a faulty. The line thickness is wrong. It is in visible line thickness, although it had to be a thin line. How it can be corrected? Indicate the break line with a click. Right click the mouse. Okay. But first say, finish the dimensioning stage, pressing escape button. Indicate the line. Right click the mouse, and from the list it will appear. Select properties option. And in property dialog box, drop the list of the standard thickness values and select 0.25 is the standard thickness for the break lines. Okay. Do the same thing for this segment. There's a little break line here. Left click, right click, properties, thickness is 0.25, and then say OK. Yes, this broken out section is correct. Well, one more time indicate this view. Okay, and then click on Start Sketch button, and then spline. Draw the boundary. I need to show this part as if visible. Okay, bound the region. This part of the projection is to be shown as if visible. Finish. Apply the sectioning process. Broken out sectioning. Clicked on this button. Indicate the same view. And then which part is to be shown? This wall. Indicate the hidden line and then say OK. Yes, that part is as if visible, but it may occur. Already shown dimensions either may be deleted or may be broken or may be shifted. Yes, you see, well, program after this breaking, well, shifted the dimensions. Don't worry about it. And also, well, you see the width of the body. I have already shown the width of the main part of the body, but after the broken out sectioning stage, the extension line just showing not the limit of rectangular prism but the limit of the broken out section. So, well, correct this mistake. Delete this dimension and then, well, hold this dimension and drag. Hold this dimension and drag. Okay. Well, show the wall thickness. Annotation. Dimension. From here to there, show this wall thickness. Okay. Well, this space, press escape button and increase it a little bit by dragging. Dimension, start the dimensioning process and then show the width from here to there. Okay. Yes. Well, the line type, correct the line type, right click. First, well, press escape button, finish the dimensioning stage, and then, well, correct the thickness value. Indicate the break line, right click the mouse, properties option clicked, and then change the thickness. 0.2 is the correct value. Now, yes, the front view is okay. Well, on the left side view, well, need to show this and that, this part as if visible. I'm going to combine these two broken out section. Well, defining the region larger, broader. Well, one time create the sectional, broken out sectional view. You know how. Indicate the view with a click. And then click on Start Sketch button. Okay, and then draw the boundary. Well, this part of the projection is to be shown as if visible. Well, sorry, I'm going to start from here. need to show this part as if visible, and then need to show this wall as if visible, this cylinder, and to be able to show this wall as if visible, then you see I defined the region large enough to bound the hidden features for which I need to show the dimensions. Okay, finish the sketching stage and apply the cutting process. Place view broken out. Indicate the same view, and then which part is to be shown as if visible. I'm going to indicate this boundary of the semi-cylinder, and then try whether gonna have this part as visible. Yes, great. Correct the thickness properties 0.25. Say okay. There is one more segment, two more segments for this segment. Okay, say that thickness is 0.25. This segment, right click properties, thickness is 0.25 millimeters. And yeah, this dimension be shifted. Well, one more time here, open a parenthesis and then explain. Well, inventor at the background using which model. Clicked on projection button and then indicate this view and then drag the mouse in the diagonal direction. Yes. Inventor using this model actually at the background in creating this broken out section. Okay, well, this dimension has been shifted. It may occur. Press escape button and hold this dimension and drag it to the correct place. Okay, now since this part is as if visible, well, the wall thickness can be shown, but this dimension, what is that? 1 millimeter. Delete this broken dimensions and then, well, show them again. Annotation dimension. Well, which dimensions? This wall thickness is one of the necessary dimension. Show. Okay. The other wall thickness, show. Yes. Location dimension for the axis of the semi-cylinder, yes, is necessary. Okay, the depth of this part, 37 is to be shown. Yes. And the overall depth of the object is to be shown, but since this is a reference dimension, because 37 plus 14 plus 12 makes 63, that overall dimension will be by definition reference dimension. Click on precision and tolerance tab and select from here reference option to take the dimension into parentheses. I have already talked about reference dimensions, and here remind you it is reference dimension. Well, the diameter of the hole, show it, yes, 6 millimeters. Okay. Radius of the semi-cylinder, yes, show it, 6 millimeters. Letter R highlights that it is radius. And the thickness of this part, this cavity, not thickness, sorry, depth of the cavity is 4 millimeters. I think can say that the views are okay. Balance the views on the paper, making such trials, the format requirement. and then the rest fill in the title block, quadrant symbol, etc. Well, I'm going to say that, well, deal with the title block filling stage, well, as your home study. Okay, I'm going to finish this video record at this stage. Well, thereafter, complete the title block. Show the quadrant symbol, write company name, general tolerance, note, okay, scale factor, material. Okay, using the text facility, you can write the necessary things. And quadrant symbol, you can show the quadrant symbol. How? I have already answered all of such questions. So if you forgot something, then find the video records in Meta class, and then the links of the video records, and then clicking on the hyperlinks, you can access to the video records and watch them again. Okay, now giving this example from the beginning to the end, while passing through all the stages, I think I managed to inform you what is my reading method. My reading method, I use the transfer lines at the view reading stage, and the other tool of my method is view creation. I create the view of the first feature, and then while after creating the models of the other features, then the already created view is up-to-dated at the background by the software, and in sequence showing the dimensions of the newly created features, I can also verify that my reading is correct, not only in shape but also in size. Yes, my dear students, I hope you understood what I mean, and then say that bye bye, finish this video record, and I wish you success, happy, successful final period. Okay, see you then during the final day. See you again. Stay healthy. Bye bye.